Hi, everybody. All right, yeah, has anybody taken that Acela train from New York? 150 miles an hour over ground. I mean, that was just, wow, I was shocked. All right, how many of you in here do blue, green, or canary, or any kind of rollout? All right, that's good. How many of you use controllers to control your infrastructure? Yeah, fewer. Oh, well, it's all right, it's not bad. Okay, if you haven't done it before, then yeah, I strongly suggest you get into it. There's a couple of vendors out here on the perimeter that have shown a bit about it. But I'm gonna show you something real quick that you might not have already seen. How many of you have done this before? No,
Are you tired of adding your clusters to every management console you use? Are you restless because you can't get your workload to scale vertically or horizontally? Do you need to clone yourself just to keep up with all the configuration variations and resource bundling tasks on your plate? All that frustration can make you cry. You need new and improved KubeStellar. With KubeStellar, you can satisfy all your multi-cluster configuration management needs. Deploy configuration to any cluster on any cloud. Hybrid, multi, edge, etc. Scale effortlessly. Centralize your inventory. Customize resources in easily defined groups. Act on status in summarized groups instead of one by one. Let automation tools do their job and return the responsibility of scale to the platform. Preserve direct compatibility with cloud-native projects using common and unbundled Kubernetes resources. Warning, use KubeStellar only as directed. Remember to exercise unabandoned joy, as KubeStellar may cause feelings of relaxation, elation, and occasional outbursts of laughter. Running KubeStellar with your choice of Kubernetes distribution and your favorite cloud-native projects may lead to periods of increased productivity and improved operations.
You like that music in the background? It's a 80s thump theme. All right, cool. Well, thank you so much for attending. Yes, I'm representing KubeStellar. The shirt plainly says. This is what we help you with here. Essentially deploy and manage your workloads from a single cluster to multiple clusters. This comes in very handy with using things like vCluster under the covers. And you're using standard deployment tools. So that means you're not bundling resources. You're just deployment, services, jobs, everything natively under the covers gets transmitted from a hub cluster to your remotes. So we can also discover objects, and that makes us useful in disconnected operations. And what I mean by that is, if any of you have noticed, when a node goes offline, it's immediately marked unschedulable. Well, in KubeStellar, that never happens. Node comes up, grabs its workload or sends its status, and goes away for long periods of time. We cover that. So my talk specifically is, you can see the source on the bottom, if any of you can read that. There was a blog post made by somebody at AWS that talked about how you might use an application load balancer with nodes in Kubernetes and deploy applications to it, and have the application load balancer then just nicely, segment the traffic, and that works perfectly. Well, my goal was to try that with KubeStellar. And so what I try to do is deploy an identical workload service to a different clusters on a platform, and configure blue-green or canary routing techniques, infrastructure, right, using only kubectl. Well, that kind of handicaps you, but this is what it kind of looks like. This is the revised version of that same slide. So you see now there's multiple VPCs involved, right? We're no longer doing service traffic, we're doing IP. So to get the traffic to reroute, well, would you use an application load balancer? Well, that was the question. I don't know how you do that, right? So imagine this is running on some single cluster, and you're telling it, hey, your targets are just services. Here, yeah, just go find them. Well, that's not possible. There's no service discovery involved there across VPC or across cluster natively in AWS or Kubernetes for that matter. So how are we going to do this? Well, one of the things that I ran into right out of the way is EKS cuddle. I mean, I was baffled by, it was a little bit too complex for me. I think I'm adept with technology, but EKS cuddle it was tough, it was a challenge for me to try and get an EKS cluster. But luckily they have wizards for this kind of thing. That's cool, it worked finally. But then VPC and VPC peering implementations, just how much information should a VPC or a VPC peer know about the services in other clusters? Well, that gets into kind of like a security context and a discussion about how much you want to elevate those privileges in order to take advantage of those types of things. So it's not really the right solution. So an application load balancer, layer 7, isn't really going to work in this context. But is there another way? Well, it turns out Route53 and something called external-dns. And this gets into, I was using a load balancer controller for ALB, but now I was using external DNS for Route 53. So really what you do is you define your service for external DNS, set up your endpoints, and then blue and green. And you can see 50% on blue, 50% on green, and then magic happens, right? Then we get overcome all those other hurdles, and we get through to what we really want, which is multiple versions of the same application running in different clusters with cluster-specific information in their metadata. So the takeaway here, external DNS is a way to update routing from a workload inside different clusters. And so if you want to know, I did document both the failure and the success journeys. I thought that was interesting and important. I thought that might have been what the organizers liked about this. But that's where you can get the code from, up on my GitHub at Club Anderson. And then catch me on Slack, Kubernetes, at Club Anderson. Thank you very much for your time.